you for coming back again, and we're going to continue with the agenda now. It's now my great pleasure to introduce to you for our mid-morning keynote, Anjul Bhambhri, who is the Vice President of Big Data at IBM. Anjul has been working with customers for 22 years in the big data space, most recently customers like Cisco and the City of Stockholm. And she was recently a recipient of the YWCA Women in Technology Award. So, Anjul, over to you.
Thank you. Thanks. I know it's hard to come back from breaks, but I guess big data is an interesting topic that at least you're all here. So I've been in the data management space for 20 plus years in relational databases. Was at Sybase, then at Informix. Then joined IBM as a result of the Informix acquisition. Joined the relational database group there, DB2. I then led the XML initiative in IBM. So from very structured data was moving towards semi-structured data. And then, of course, like you've all been seeing and hearing, this emergence of big data, it made sense from a data management standpoint that we look at how we can help customers, how we can help our partners really get their arms around what the industry is calling as big data, and not just collect this big data, but how do we help them analyze this data and get more information out of this. So, I'll share some examples of what we've done with customers, what we are seeing as trends in different industries, and, hopefully make it useful for you for the next 30 minutes to hear more about what's happening in this space. Thank you. Let's see if we can get this thing to move. So I think we've heard a lot about where is big data coming from. It's certainly there is with what we are seeing from what is happening in the social media with Facebook and Google and Twitter. Just the amount of data that is getting generated by all of us as users has been really mind-boggling. Just to throw like a stat in there that collectively we are generating like 2.5 quintillion bytes of data every day. I mean, that's a large amount of data, and this is certainly a new trend, and with the activity on the internet and the social media, certainly this data is huge and something that is also useful from various perspectives. And the actual size of the data here is not as important, but because anything that we put up here, that Twitter with 12 plus terabytes every day, this gets outdated from every day. This data just continues to grow. So I won't focus too much on the exact size here, but in terms of the volume, this is huge. Same thing from Facebook, right? Like the log data that is getting generated is almost like 25 terabytes. And close to about 7 to 8 terabytes of this log data is actually getting on the web. And there is, again, a wealth of information hiding in here, which, if not tapped into or analyzed by certain kinds of businesses, they could be losing out on a lot of information. Of course, we know Google with Google Maps and Mail, Gmail, all kinds of things. Again, tons of data getting generated. So this is really the social media aspect of it. Then there is, of course, a lot of everything these days has some kind of sensor device attached to it. So RFID tags, this was when we looked at, like, there was news, some time back. There was a bridge in Minneapolis that fell, And when that bridge was getting reconstructed, it was pretty clear that this could not be reconstructed without putting a lot of sensors in that. And what were these sensors doing? From these sensors, now data is being gathered that, how much is the concrete contracting based on weather conditions, based on, the snow and the ice buildup on the bridge, which was not captured before. And if that kind of information can be captured, things can be predicted that, if this level of contraction is occurring in the concrete, it could lead to dangerous situations. So this sensor data is not, is not just being gathered for the sake of it. There is, again, a wealth of information that is hiding in here, which needs to be analyzed to prevent disasters like what I just shared as a bridge collapsing because that data could not be analyzed. Of course, big data is in the news everywhere. Whichever conferences you go to, you pick up magazines, it's talking about big data. You Google on big data, and there are lots of the searches that come up is huge. So it's pretty clear that people are really paying attention, becoming aware, want to read about it, want to understand that what are the possibilities of harnessing this data. And there's just tons of information that is available around this. In Information Week, there was an article around that this is not just about gathering the data. And Bruno, this morning, the keynote speaker from Microsoft, alluded to that as well, that gathering of data has been happening for a long time. But now I think the time that is, why it's really exciting is that the technology that is available that is now can be used to harness, analyze this data has become available, and it is not cost prohibitive for customers to really embrace this technology, bring in all of this data, and really analyze all of this data. So, what we saw before was because of technology limitations or from a cost standpoint, customers were wary that even though they had the data, they were only analyzing subset of that data because it was just too expensive to analyze all of the data. It was not just, it was expensive, and the time that they would need to analyze all of this data would be, by that time, that data might become irrelevant. So we'll spend some more time in terms of what the technology, yes, we've all heard of Hadoop and MapReduce, how that is really enabling enterprises to embrace and bring all of this data in their decision-making process. And in this article, like in Information Week, one of the customers that Doug mentions is Catalina Marketing. So this is a customer which, they analyze, they do market research for almost close to like 195 million users who are in various loyalty programs around with supermarkets and pharmacies. And all of this data was being analyzed. This is all structured data, right? So when we talk about big data, we think of unstructured, semi-structured, but there's also a wealth of information which is still in structured data. And so to the point that Doug was making, that Catalina Marketing, right? They had put 600 billion rows in one single table, which had all the information about 195 million users of, what kind of products they buy, what's the buying pattern, where do they buy this, what kind of promotion should be offered to them. And this was 2.5 petabytes of structured data. So relational databases are not something that we just throw away as we are thinking of analyzing a lot of this big data. From the standpoint of what we hear from our customers, right, that a lot of the big data is characterized by, we heard this morning about the 3 Vs, that one aspect is the volume, that there's a large amount of data. Relational databases have been handling a lot of the structured data in large volumes, right? So that is not something new. But the characteristics that we are seeing in some of these new sources of data is that there's no structure to the data. A lot of it is semi-structured or unstructured. So it's very difficult at times to analyze this data by jamming it in a warehouse or in a relational database. And that's what kind of differentiates this, and that's why the industry, I think, really came up with the term called big data, because you look at that it's not just about the large volume, it's about different kinds of varieties of data. It's structured, semi-structured, unstructured, and the speed at which this has to be analyzed and is getting generated is pretty fast. Right? Like if it was taking, say, 30 days to put this data in a warehouse and analyze it, now businesses need that this has to be analyzed in less than 1 minute. So the traditional approach of putting it in a warehouse and analyzing it is not going to work, because in certain cases, like I said, if it was taking 30 days to get it in the warehouse and analyze it, when business need is that this data needs to be analyzed in less than 1 minute, that the technology needed, which was used before, is not going to work. So and not all of this data is useful. So there is a lot of noise in this data. So this data is very sparse in certain cases. So the ratio from the standpoint of the actual value in this data to the noise in this data is pretty high. And what's happening is that from the standpoint of enterprises, this is sparse data. They really don't know, is there real value in this data? Should we be really spending our time and money and technology to harness this data? But what they're finding is that they cannot even ignore this data, because if there are even if there is some amount of information that is hiding in here, if they are not leveraging that information, then they could be at a disadvantage compared to their competitors. So this is not something that, at least so I work with a lot of the CIOs and CTOs of companies, where we advise them that this is not something that they can just ignore. It's important for them to explore this data, see what kind of information is in this data, and then decide, what's the best way to harness this, what's the best way to use it in their decision-making process. And one of the concerns that comes up consistently from the decision makers is that they're worried about this, right? That they're worried if they don't look at this data, that they're losing out on information which they should have actually considered while making decisions. So that comes up in a consistent manner. Now, a lot of times they don't know how to start, where to start. Is it too expensive to start? It may seem like, for all of the folks here who may spend a lot of time working with the technology, that, the starting point is simple. But, for big enterprises where they are sitting with maybe petabytes of data which they have not tapped into, which they have not looked into, it seems like a pretty daunting task, right? That now if we haven't analyzed this data for the last 5 years, now how do we start this journey? But at least, if they recognize the fact that they are making decisions based on maybe just 20% of the data and not, the 100% of the data that is available to them, then at least you have a starting point to get a dialogue going and really help and get them on this journey of big data. So this is just that one of the things that we always say to them is that raw data is not just going to do it. So it's not enough to just gather this data and keep gathering more data. Most companies, most enterprise customers, most big companies are very good at gathering data. Like, it's very interesting to find how much data they are sitting with. But analyzing the data is a separate story, and which is where I think, collectively, we have to make sure that we are really helping these customers analyze this data and be able to gain insights from this data. This is important for them because they realize that as they are able to tap into these new sources of data, they are able to gain insights which gives them advantages compared to their competitors. In a lot of cases, right, there is a lot of information that has been logged within an enterprise. And by not analyzing these logs, they are not able to gain insights as to how can they make their operations, doesn't matter what it is, more efficient. So being able to get strategic advantage from this data, being able to improve their operational efficiency, being able to understand their customer better is all possible with big data, is something that, as I share some examples, will be pretty clear as to how why people are caring about big data, why they want to look at solutions that are going to help them. When we look at just the use cases that we see of what are people doing with big data, certainly understanding their customer or getting a 360 view of the customer, whether it's a customer in a true sense of, like a retail industry caring about what their customers are wanting, whether it is, hospitals that are catering to patients, that, what do their patients, what are their needs? Is there, are their needs being met by the services that are being provided? So every business obviously wants to have a good understanding of are they servicing their customers in the best possible manner. And for gaining that 360 view of the customer, it's important for these companies to analyze all the data that is available to them about a customer, right? There is obviously, a lot of companies will have CRM systems, but there's only certain kind of information that may be captured in a CRM system. And if that's the only thing that is being analyzed, well, then that's the only information that you can get about your customer. But if that is, complemented with other sources within their enterprise, which also might be gathering customer information, if that could be augmented with what's happening on the social media, what are their customers saying about them on that social media, then they are expanding what they know about their customer. So, the 360 view of the customer is a big problem as well as a possibility now with big data that, businesses can actually make it happen. So, there's obviously a lot of talk about big data in terms of social media, but we've done a lot of work in the healthcare industry, which also has tapped into big data and analyzed this data to prevent and predict life-threatening situations. And I'll go through this example in more detail with the work that was done with University of Ontario in Toronto in an ICU unit around newborn babies. Similarly for energy and utilities, right? So there's a lot of sensor data that is gathered in the energy and utility industry. Now, what is that data? It's gathered, but a lot of it was not analyzed. Again, a subset of the data was getting analyzed to make some predictions, but now with the technology that we are seeing is really making it possible for all of this data to get analyzed. So from the standpoint of big data is in the retail industry, it's in the healthcare industry, it's in energy and utilities, financial sector. From a security standpoint, there is a lot of a big data challenge in the government. There is tons of data that is gathered there, which needs to be analyzed. So it's not limited, unique to any one specific sector. This is pretty pervasive, and the requirements to analyze it applies to all of these industries. So, I was mentioning about the work that we did with University of Ontario in Toronto. Now, this is with the ICU unit, and they have, this is where the premature babies are brought in. And there are, with the number of sensors that are attached to these babies, in combination with, the doctors and the nurses' notes that are, captured during every round that is taken, there are almost close to 1,000 pieces of information that are gathered about every baby per second, right? And what was done here was that we worked with with the research center here, and we helped them that by using the technology, they were able to analyze this data, which is coming in per baby, 1,000 pieces of information per second. And you can read about it more, if you go to the IBM's website. And the end result of this was that by analyzing this data and seeing certain patterns emerge in the data, the doctors were able to predict onset of an infection in a newborn baby 24 hours in advance. And, we can discuss offline if there was interest in, how we actually, how all that happened. But this was the outcome here. And this is pretty, like when you look at this, right, that being able to predict the onset of an infection 24 hours in advance, I mean, that's a significant amount of runway that is given to the doctors to actually do something, because losing 24 hours for a newborn baby, it is pretty much can lead to a fatal outcome. So when we think about big data, this is these use cases and examples are pretty near and dear to me, because they show that this is not just about social media, right? I mean, while that is interesting, that is fascinating, but being able to analyze this data is critical in situations like this. And then this work was taken forward to Columbia University, where something similar was done for stroke patients. So in all of these cases, the important thing here was that this data could not have been taken and put in some warehouse, cleansed, and figured out like a month later that, oh, this was the infection that was emerging and something should have been done about it. So the latency here had to be really low in terms of how quickly this data had to be analyzed. And I think that was, this is something that is very important, that not all of the big data can be analyzed in a batch processing kind of a mode, right? There is also the aspect that a lot of this data has to be analyzed in real time, so that, this is not something that we are waiting for an outcome, after a month or a day even, right? So this is an important aspect of big data. Same thing from, this is work that we did with the city of Stockholm, then it went to Zurich, then it went to Kyoto in Japan. And this was all around, again, a lot of sensor data being gathered from GPS devices, from stoplights, from stoplights at intersections. And what was done here was two main outcomes here to solve a traffic congestion problem. One is that as all of this data was coming in, that this data was gathered for over 2.5 years. There were predictive models that were built by analyzing all of this data to predict that if this kind of a pattern starts emerging, it would lead to a traffic bottleneck in a certain area. So that was fed to the city planners so that they could, for the future, see that with all of this data, with all of these people on the road between, this time in the morning to this time, or this time in the evening to this time, these are the kind of bottlenecks that are created, so that they could plan better looking ahead, how do they remove those bottlenecks? So that was one aspect. The second was that some of these cities have created, real-time services that people can subscribe to. So as they are commuting, if there is a traffic bottleneck or some problem that has happened in the route that they would be taking, they get alerted and alternate routes are suggested to them. And this is, again, a big data problem, lot of data, which was analyzed for historical reasons to predict, what to do in the future, as well as there's a real-time aspect to it. And, given that it has gone to 3 cities, shows that, this is something that people are finding useful. Same thing for now this energy and utilities industry. This is a company in Denmark. It's Vestas. And this is a wind turbine company. And what they do is they have wind, they have weather data. They have sort of like a library of data, which they say that if somebody were to watch how much data they have, it would be like watching 70 years of HD TV, right? So that's how much data they have. But were they analyzing it all? No. So they were putting this data. This is all structured and semi-structured data. There's no unstructured data here. And a lot of this data is, again, sensor data that is coming. Wind turbines generate a lot of data, coupled with weather data and satellite images and things like that. So what they have to do is they have to be accurate in where the wind turbine has to be placed on the earth so that you can get maximum power generation out of it. And if that is that prediction of where to put that wind turbine is not accurate, that means you get suboptimal power generation. So what they've done now, so before they used to analyze a very small subset of the data. Now, because they are analyzing almost like close to 2.5 petabytes of data today, moving all the way up to about 6 petabytes by the end of this year. Since they are analyzing large chunk of data, so their models that are built to really predict, where to place these wind turbines are better, right? Because it's not based on a small subset of data. It's based on a bigger subset of data. And so because it costs them about $4 million to place a wind turbine. And once an asset is placed somewhere, its lifespan is about 30 years. So if it gets placed in a wrong location, then it's a lot of money down the tube. So it's very important for them that the placement be accurate. And, there's a lot of just some data points there as to how they've been able to improve the accuracy and hence improve the power generation. Cisco, something that's a company in the Valley. So again, some work that we did with them around big data was, gathering a lot of sensor information and being able to optimize the energy utilization in buildings, right? So there is a lot of money that is spent by businesses in running a building because of the, where to heat up stuff, when to switch off, when you can lower the air conditioning. So this is an initiative that Cisco has around their smarter buildings. And this is being taken worldwide. Again, what was done here, lot of sensor data gathered, analyzed to predict that if this kind of things were done, then, you could have reduced your energy consumption. So the thing here is that, big data is, you can take, like in this case, there were like petabytes of log data that they have, right? So all of these devices generate a lot of logs. But, analyzing log data has not been easy. So in this case, right, with now the advancements that have been made in the technology, that we were able to analyze their logs, and they generate like 200, 300 terabytes of log data. And, this is every year, right? So they had log data that they'd already collected for years, and then there's about 200 to 300 terabytes coming every year. So we had to do historical analysis, and then as more data comes in, be able to correlate whatever was gathered and analyzed from the historical data with the new data that was coming in. So again, this is something that they're taking to China and Korea as a way to help businesses there optimize their energy consumption. So in the interest of time, I will skip through some of these examples, but you can imagine that, again, telecommunications, there are a lot of call data records. So this is, one of the telecommunication providers that we worked with. They have to analyze about 6 billion call data records a day. I mean, that's huge amount of data. And why do they do it? They want to figure out if there are billing disputes, if they can gain information to solve those billing disputes, any kind of customer churn that can be prevented by gaining information and insights from those call data records. Again, this is something that from a big data standpoint, analyzing call data records in the telco industry is a very, very prominent, is a very important aspect of the kind of data that they have to analyze, because there are a lot of insights to be gained from here. So, when we talk about that, okay, what's the on the left-hand side, you see a lot of the use cases that we are seeing around big data. And what we see on the right side is what we recommend to the customers, that as they are trying to solve their big data problem, they have to look at technology or a big data platform that is going to help them analyze all these different sources of data, be able to deal with not just unstructured data, but structured and semi-structured data, be able to deal with the velocity or the speed at which this data is getting generated, be able to analyze this data from a historical standpoint, as well as be able to do it in real time, because in a lot of cases, the latency has to be very low, because if it takes 30 days to analyze the data, it's kind of meaningless. And be able to obviously get the right kind of reports and be able to visualize, see what patterns are emerging in this data, really do enable these enterprises to do a lot of the data discovery and exploration. And at the same time, it's very important that they don't build another silo which only deals with big data. It's very important that as customers are looking at this big data problem, that whichever technology they bring in to solve these problems, it has to integrate and work with the operational data stores or the warehouses or any custom applications where their data might be getting stored. It helps to integrate it all, because replacing that, you already have, say, 5 silos, and we create one more silo which is only dealing with big data is not going to address the problem where you really want to analyze all of the data that is available to you to make decisions. So this is, I think I would say we are all at the start of this journey here. This is, not something that I would declare victory. There's a lot of work to be done here. There's a lot of opportunities that are available, both in terms of solving the problem from an infrastructure standpoint, in terms of how do we analyze this data, and the custom solutions that would sit on top of this infrastructure, where some customers may just want to go with the solutions or custom applications to solve the kind of problems that we list on the left-hand side, and be able to buy a complete solution as opposed to building it on their own. This clearly, from a big data standpoint, when we looked at the traditional approach of what we had seen, warehouses do before, that businesses were very much used to ask the question and IT would give them the answer, right? So it was predetermined set of questions and predetermined set of reports that were being exchanged between the business users and the IT users. But what we are seeing with big data is that a lot of times it's not clear to the business users, what is the data telling me? What trends am I really looking for? What kind of question should I really be asking here? So that traditional approach of, here's the question, give me an answer, is not going to work here. And so there's a big switch where what the business users really want to do is just experiment. They want to see, they want to explore the data without really even first telling IT that these are the kind of reports that we want. And that's why, I know, Bruno was alluding also in the morning, that how the tools that are emerging in this space, which will really help and empower the business users to be able to ask the questions, to be able to do that ad hoc analytics on this data without really these things becoming, quarterly or monthly or daily reports. I mean, it may eventually go there, but it's not going to start that way. So when we work with enterprise customers, we talk to them about that as the data comes in your enterprise, that's where you want to do exploration. That's where you want to really see what is this data telling you. And then there may be some subset of that data, because like I said early on, that a lot of this big data is sparse. The signal to noise level is pretty high. So you want the signals, but you want to filter out the noise. And once you've spotted the signals, it's possible that that subset of the data may actually need to be moved into the warehouse or need to be moved into an operational data store. It depends from use case to use case. But there is definitely the aspect of exploring big data, really integrating it with the rest of the systems that the customers may already have there, and then again obviously continue to for the decision makers to continue that they have to get answers to their questions, which is now examining all of the data and not a subset of the data. So I think this is what would give strategic advantage to the businesses if they can really get their arms around this and be making decisions based on the complete set of information that should be made available to them, as opposed to some subsets of data, because then those decisions could be wrong. So this is, I think, a lot of work that has happened in the open source community certainly plays into this. There's a lot of work that is happening from an analytics standpoint that plays into this. From a tooling standpoint, how do you visualize, how do you explore this data? So tremendous amount of work that has been done by various companies, and each one of them has something really compelling and good, but I don't think we are done with solving all the challenges. So thank you.